Hello, today I'll be presenting my findings after doing the molecular docking of SOD1 with APGenin. So the protein that I got was superoxide dismutase 1 SOD1, which is against the disease ALS. ALS is amyotrophic lateral sclerosis, which is a neurodegenerative disease. The ligand I got was APGenin, and the tools I used for molecular docking was the main software that I used is PyRx, and molecular docked using AutoDock Vina, which was integrated into PyRx, and I used OpenTable to prepare the ligand. Then the different poses that I obtained after molecular docking was split using Vina split, and the visualization was done by BioVia Discovery Studio. I also prepared the protein. Initial preparations were also done in BioVia Discovery Studio. So, what is ALS? ALS is, as I said, amyotrophic lateral sclerosis, which is also known as motor neuron disease or Lou Gehrig's disease. It is a neurodegenerative disease that causes progressive loss of motor neurons, which control voluntary muscle contractions. So, there are SOD1, we know from several studies that SOD1 mutations are linked to familial ALS. Before that, what is SOD1 protein? SOD1 protein is a powerful antioxidant enzyme that protects the cells from the damaging effects of superoxide radicals. So this enzyme SOD1 binds to zinc and copper ions that are directly involved in the deactivation of toxic superoxide radicals. And before we talk about APGenin, we have to know talk about the pathogenesis of NRF2 ARE signaling pathways that causes a lot of neuron deaths and in turn causes ALS. So a specific signaling pathway NRF2 slash ARE and the inactivation of it is a key attenuation of antioxidant defenses and the resultant oxidative damage to neuronal cells. So we can increasing the activity of NRF2 pathway can improve neurological function and prolong survival in ALS. And that's where APGenin comes in. APGenin is a natural flavonoid with neuroprotective properties. APGenin has, through various mechanisms and research, we have known about the neuroprotective properties of APGenin, and one of the key mechanisms that it does is activation of NRF2 slash ARE signaling pathways, and thereby enhancing the cellular antioxidant defense system. So we know from this connection that it can improve symptoms of ALS and prolong survival. And my aim throughout this project was to evaluate the binding of APGenin with SOD1 using molecular docking and find the best binding sites. The protein, I acquired the protein from a database called UniProt. From UniProt, a UniProt linked PDB that I downloaded an MMCIF file from a UniProt linked PDB database. Then the ligand was acquired from PubChem, which was downloaded as a 3D STF file. The protein was prepared. The initial preparation of the protein was done in BioVia Discovery Studio, where I uploaded the protein and converted and deleted all the removed all the unwanted water molecules, het atoms, and unwanted protein subunits, and then converted and then saved it as a PDB file. The ligand this protein PDB file and the ligand was uploaded to PyRx, where using open label, I prepared the ligand and added charges and minimized energies. And then I further prepared the protein, and both were by adding charges, and both were converted into a PDB QT format, which I then used in molecular docking using AutoDock Vina. After the docking was done, I got about 9 different ligand poses, which was then split using Vina split. The visualization of the molecular docking was done by BioWare Discovery Studio. So the docking resulted in 9 binding poses. The best pose was the mode 0, which gave a score of minus 8.2 kilocal per mole, which is a very good score in Vina, I suppose. Other poses ranged from minus 7.9 to minus 6.8, which indicates a very stable and favorable binding of this ligand to a protein of interest. Then this is the visualization using BioWare Discovery Studio. This is the 3D structure of the dock complex. This is a more zoomed in version which shows the 3D interaction map. We can see the carbon, the conventional carbon hydrogen bonds, conventional hydrogen bonds, pi sigma bonds, pi alkyl bonds, etc. This is the 2D interaction map. We can see here the different interactions that are happening in which is van der Waals forces, conventional hydrogen bonds, carbon hydrogen bonds, pi sigma and pi alkyl bonds. So what can we interpret from this interaction? We can see that it is the ligand is stabilized to the protein by hydrogen bonds, van der Waals force, pi alkyl and pi sigma interactions. It confirms that the accommodation of the ligand to the protein pocket. So through different literature, we know that some of the known SOD1 modulators or inhibitors are epsilon and LCS1, and from what I got from the data that I got, Epigenetic shows comparable interaction patterns with these known modulators, and this suggests Epigen as a potential lead compound in drug discovery for ALS. But this comes with limitations because molecular docking cannot, for a fact, say that this ligand can be used in drug discovery, because docking is a very static approach, as written here, because it doesn't fully capture the protein flexibility, doesn't fully take into account the protein flexibility, ligand flexibility, the solvent effects, and this can only be known by further molecular dynamics and experimental approaches. So the conclusion from this is that Epigenin binds very favorably with SOD1. The docking scores support this fact, and this does serve as a promising candidate for ALS research. Thank you.